For we to obtain the variance, we look for the expected value of x squared, which for continuous distribution is equal to the integral of x squared multiplied by f of x dx, as the integral ranges from 1 to 0. So this is what we get. The next thing to do is just to impute the beta distribution into this function. But this function is the beta distribution in this case. So we substitute the beta distribution into this function. So we move over to this other side again. We move over to this other side. It then means that our expected value of x squared will be equal to the integral, as is ranging from 0 to 1, x squared multiplied by, so we use our distribution, the beta distribution, which is 1 all over alpha beta multiplied by x raised to the power of alpha minus 1 multiplied by 1 minus x into beta minus 1 dx. So we can bring this out to give us 1 all over beta distribution into alpha beta integral of, if we combine these two, we'll get x into alpha minus 1 plus 2 into 1 minus alpha, sorry, 1 minus x raised to the power of beta minus 1 dx. Of course, this will now give us alpha plus 1. So, ranging from 0 to 1. The whole of this function, which is equal to 1 all over alpha beta into 0 to 1, the whole of this will give us x raised to the power of alpha plus 1, 1 minus x beta minus 1 dx. This function implies our expected value of x squared is equal to 1 all over beta distribution multiplied by, the whole of this function will give us our beta distribution to be alpha plus 2 then beta. So it then means that our expected value of x squared is equal to alpha plus 2 beta into beta distribution alpha beta, which is equal to, we'll now write the whole of this function. The whole of this function will give us we are using the gamma function to write it. We'll have alpha plus 2 multiplied by beta all over alpha plus beta plus 2 all over, we'll now write that of this function, which is alpha multiplied by beta all over alpha plus beta. So this is what we get for this function and this function. So the next thing to do is to rewrite it properly here. The next thing to do is to rewrite it properly this way. We should not forget that our expected value of x is equal to alpha all over alpha plus beta. We should have that at the back of our hearts because we come to read. So we have our expected value of x squared to be equal to alpha plus 2 beta all over alpha plus beta plus 2 multiplied by, this will come over as we are multiplying to give us alpha plus beta all over alpha multiplied by beta. So this is what we get. We can also open this. This can give us the whole of this. Of course, this will now give us alpha plus 1 alpha alpha multiplied by beta. This and this. All over, the whole of this will give us alpha plus beta plus 1. We are splitting it into alpha plus beta into alpha plus beta for the gamma function multiplied by alpha plus beta all over alpha multiplied by beta. So that is what we get. That is what we get. Of course, some things can also cancel. Of course, this can cancel this will cancel this will cancel this. So our expected value of x squared will be equal to the remaining function, which is alpha plus 1 alpha all over alpha plus beta plus 1 into alpha plus beta. This is what we get as our expected value of x squared. And we should not also forget that we got, for our expected value of x, we got alpha all over alpha plus beta. So we got this too because this is what we need to get our variance. So how do we calculate for our variance? We come over to this place. We come over to this place, calculating for our variance. For we to calculate for our variance, we should note that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. The next thing to do is to impute our values for expected value of x squared, which is this. So we'll write this out to give us alpha plus 1 alpha all over alpha plus beta plus 1 alpha plus beta minus this function alpha all over alpha plus beta all squared, which is the same thing as alpha plus 1 alpha all over alpha plus beta plus 1 alpha plus beta minus alpha squared all over alpha plus beta squared. So this is what we get. It then means that our variance of x is this. The next thing to do is to rearrange this properly. Of course, this will multiply this to give us alpha plus beta squared multiplied by alpha plus 1 alpha minus, of course, this will multiply this to give us alpha squared into alpha plus beta plus 1 multiplied by alpha plus beta all over, we'll combine the whole of this as the LCM, which is alpha plus beta plus 1, alpha plus beta, and alpha plus beta squared. The whole of this becomes our LCM. The next thing to do is to bring out something is common, alpha beta. Alpha plus beta is common, so we bring it out. So we have alpha plus beta into alpha plus beta multiplied by alpha plus 1 alpha minus alpha squared into alpha plus beta plus 1. This will come over all over alpha plus beta into alpha plus beta squared into alpha plus beta plus 1. So this will cancel this. We'll now be left with the whole of this function. So we move over to this place. As we have this, the next thing is that we move over to this place so that we can get our variance. We only look for the expected value of x, so we can get our variance. Our variance of x will now be equal to, of course, this multiplied by this, we now have alpha plus beta. We can open these brackets to give us alpha squared plus alpha minus, we open the other brackets to give us alpha q plus alpha squared beta plus, minus alpha squared all over, this remains the same, alpha plus beta squared into alpha plus beta plus 1. This is equal to, we can multiply this to give us alpha cube, this multiplied by this, plus alpha squared beta, this multiplied by this to give us plus alpha squared, this multiplied by this to give us alpha beta, minus alpha cube minus alpha squared beta minus alpha squared all over alpha plus beta squared into alpha plus beta plus 1. Of course, some things here can cancel so that we get our variance of x. Alpha raised to the power of 3 will cancel alpha raised to the power of 3. Alpha squared, beta squared. Alpha squared, beta squared will cancel. Then alpha squared will cancel. It then means that our variance of x will be equal to what we have left is alpha beta all over alpha plus beta squared into alpha plus beta plus 1. So this becomes our variance. This is our variance and this is our expected value of x. So this is how we can obtain the expected value and the variance for the beta distribution. If we follow through these processes, it will be very easy for we to compute the expectation of the beta distribution and the variance of the beta distribution. So we have as our final answer the variance of x to be this and the expected value of x to be this. For more on this topic, you need to subscribe to this channel.